Good afternoon to all. Okay. Today we are going to discuss about one of the very important topic, that is radius of gyration. What? Radius of gyration. Listen properly, one by one. Okay. Symbol for this K. Okay. Already you got discussed about moment of inertia for regular objects. Example, uniform rod, uniform ring, and a uniform disc, etc. I am correct or not? Yeah. But here, one of the new formula for moment of inertia introduced. It is applicable for irregular objects and non-uniform distribution of mass. Keep in your mind. But in last class, mass is distributed but uniformly. I am correct or not? In regular objects. But this general formula applicable for irregular objects and non-uniform distribution of mass. Okay, listen properly. Here consider one rotating rigid body. Okay, listen. Irregular object. This is axis of the rotation. Okay, you know that very well. Rigid body contains lot of point masses, no? Yeah. So, point mass m1 at a distance r. Point mass m2 at a distance r2. Point mass m3 at a distance r3 from the axis of the rotation, that is important. Point mass m4 at a distance r4. This is axis of the rotation. This is rotating rigid body. Okay, yeah. So here introduced the general formula for moment of inertia of irregular object, that is I is equal to mk square. I is equal to mk square. Okay, it is applicable for irregular objects and non-uniform distribution of mass. This is the general formula for moment of inertia. M means here total mass of the object. Total mass of the object. Clear? Listen properly one by one. K means here radius of gyration. Okay. What is meant by radius of gyration? Listen properly. Now we are going to discuss about definition of radius of gyration. Listen properly, very very important this. Symbol for this K. So radius of gyration of the object is the perpendicular distance from the axis of the rotation. Radius of the gyration of the object is the perpendicular distance from the axis of the rotation to an equivalent point mass, which would have the same mass as well as the same moment of inertia of the object. Keep it in mind. This is the definition of radius of gyration. Okay, perpendicular distance from the axis of the rotation. That is important word. Just underline in your textbook. Come on, fast underline. Clear? So general formula I is equal to mk square. M total mass of the object. K radius of gyration. Okay. Then moment of inertia. General formula already we have discussed. Am I correct or not? I is equal to summation mi r square. Am I correct or not? In last classes. Okay. Here I is equal to 1 to n point masses. Okay. So I is equal to, for this, m1 r square, or before that here just consider one of the rotating rigid body. Already we have discussed about this in last classes. At the same time, this rigid body contains a lot of point masses. I am correct or not? Like this, m1 at a distance r1 from the axis of rotation, m2 at r2, m3 at r3, m4 at r4. I am correct or not? Yeah. So let us consider one of the rotating rigid body of point masses. Listen. From m1, m2, m3 up to mn, n point masses. Its distances r1, r2, r3 up to rn. Okay. Therefore, moment of inertia I is equal to summation mi r square. Here I is equal to 1 to n. Okay. So now I is equal to, for this, m1 r1 square plus m2 r2 square plus m3 r3 square plus up to mn rn square. Okay, simplest topic this, but formula is very very important to solving the 1 mark problems and NEET also. Listen. Now, if m1 is equal to m2 is equal to m3 is equal to up to mn is equal to m, that means same as. Okay, so now we can write as I is equal to m r1 square plus m r2 square plus m r3 square plus up to m rn square. Okay? Say no, taken outside. So, I is equal to m r1 square plus r2 square plus r3 square plus up to rn square. Okay? Now, if multiplied by and divided by n, this term. Therefore now I is equal to nm r1 square plus r2 square plus r3 square plus up to rn square whole divided by n. That means n point masses. Okay. From this term, listen properly. What is nm? Yeah, very good. Correct. You are correct. Total mass of the object. I am correct. So come on. Here nm is equal to total mass of the object. Nm is equal to total mass of the object. It is equivalent to capital M. Capital M means here total mass of the object. Total mass of the object. So I is equal to m, and here r1 square plus r2 square plus r3 square plus up to plus rn square whole divided by n, it is equal to k square. Okay, come on. It is equal to k square. Here k square is equal to r1 square plus r2 square plus r3 square plus up to rn square by n. Very important term this. Okay, or k is equal to square root of, okay, r1 square plus r2 square plus r3 square plus up to rn square by n. Okay, from this term, k, come and tell me what is the meaning of k? K indicates from this term or from this formula. Yeah, very good. You are correct. What? Root? Very good. Root means square. Very good. Root means square distance. So k indicates from this equation. K means radius of gyration. It means root means square distance of the particles. Root means square distance of the particles from axis of the rotation. From axis of the rotation. Clear? Therefore, it is called the radius of gyration. Very important formula. See here one by one. Again. One by one. Clear? Any doubt? Shall we go to next one? Okay. Next, we are going to discuss about one example problem, but it is used to, this example used to calculating k value. What is k? Yeah, radius of gyration. What is the definition of radius of gyration? Come on, tell me. Compulsory you memory these 4 lines. That means this statement. Otherwise, you cannot use the formulas for solving the 1 mark problems. Yeah, radius of gyration of the object is the very good perpendicular distance from the axis of the rotation. Perpendicular distance from the axis of the rotation to an equivalent point mass, which would have very good the same mass as well as same moment of inertia of the object. Clear? Yeah. Therefore, here now we are going to see about one example problem. Listen here. Okay, already you have discussed about moment of inertia for regular objects. Uniform for uniform rod, already told you. Uniform disc, uniform. But here considered uniform rod. Come on, listen. Uniform. So consider one uniform rod of mass m. Its length L. Its mass caps M. Its length L. Here mass uniformly distributed. I am correct or not? Because of this is a regular object. So, come on, anybody, come on, anyone known person. What is moment of inertia of this uniform rod? I think page number 234. Come on. Moment of inertia of uniform rod of mass caps M, its length L, about an axis passing through the center. Very good. Center of the uniform rod. Passing through the center of the uniform rod. So axis passing through the center of the uniform rod and perpendicular to, very good, length of the uniform rod. Perpendicular to length of the uniform rod. Axis passing through the center of the uniform rod and perpendicular to length of the uniform rod. Come on, anybody? What? Very good. Come on. I is equal to 1 by 24. No, you are wrong. What? Yeah, very good. 1 by 12. Very good. ml square. Moment of inertia for uniform rod of mass m, its length its length L, about an axis passing through the center of the uniform rod and perpendicular to length of the uniform rod. Very good. That is correct. I is equal to 1 by 12 ml square. Okay. In terms of radius of gyration, in terms of K. K means radius of gyration, no? Yeah, very good. I is equal to mk square, very good. It is very, very important. Come on, listen. Because like this type of problem compulsory may ask in your examination, NEET or theory examination from part 1, that means from 1 mark. Very, very important. After studying or understanding about this, 1 mark in your packet or 4 mark in your packet in NEET examination. So listen properly. In terms of radius of gyration, I is equal to mk square, no? Yes, very good. You can equate these two equations. Am correct or not? Yeah. mk square is equal to 1 by 12 ml square. Very good. Clear? That's all. Cancel. K square is equal to 1 by 12 L square. Yeah, very good. We are going to calculating K value, that's all. Yes. So K is equal to root of 1 by 12 L square or 1 by root 12 into L. Clear? Root L square cancel and on root for 12. So listen, 1 by, we can split this number as 4 into 3. Am I correct? Yeah, very good. 4 3 is 12, no? Yeah. Into here. Then 1 by 4 root 4, yeah, 2 into root 3 into. Am I correct or not? Yes, very good. So 1 by 2 into, for root 3, yeah, 1.732 into. Okay? Now 1 by 2 into 1.732, 2 2s are 4, 2 3s are 6, 2 7s are 14, remaining 1, 2 1s are 1, yeah, plus 1 3, so 1 by 3.464 into L. Come on, divide it quick. What? 0. See the log first. Very good. 0.288 into L. So K value 0.288, 0.288 L. That's clear? Very simplest topic. Okay? Any doubt? See one by one. Come on. Come on here. Come here. Here. Any doubt? See one by one. Come one by one. Come here. Here. This formula. This example. Yeah. K calculating method. Calculation of K. Come here. Any doubt? Very simplest topic this. Okay. Thank you.